After discussing the Kelvin cycle, we will discuss now our doubts of C3 cycle. All the doubts already we have cleared, and these are the MCQ, the powerful MCQs that are present here, and you will face these questions in every exams from C3 cycle. What is their first formation? Let's start. The formation of phosphoglyceraldehyde, 3-PGLD, okay, that is PGLD, phosphoglyceraldehyde. From phosphoglyceric acid, first type of reaction, from acid to aldehyde, always reduction, okay. From acid to aldehyde is a reduction, and from aldehyde to acid it is oxidation, okay. You have to remember it. So whatever reaction, it is reaction. However, if Kelvin cycle runs 3 times, Kelvin cycle runs 3 times, that is 3 CO2 is added, okay, how many PGLD will be produced? So how many PGLD will be produced? For one cycle, 2 molecules of PGLD are formed. So for 3 cycles, it is 6 molecules of PGLD will be formed. At the cost of what? ATP and NADPH. What type of, how many ATP and NADPH are produced? Okay, up to the formation of PGLD, not regeneration here, you have to consider only the PGLD formation. So up to the PGLD formation, you have to lost how many ATP per cycle? 1 PGLD per cycle, that is 2 PGLD are formed, okay, per cycle. So for 2 PGLD, 2 ATP and 2 NADPH are required, okay. Up to this PGLD formation, 2 ATP, 2 NADPH, okay. So here you will see that 3 cycle, 3 times, so 3 into 2, that is here for 6 PGLD, here that is 6 PGLD. How many molecules? Then are 6 ATP, 6 answer is 6 ATP and 6 NADPH2 will be required to produce what? 3 times running the Kelvin cycle, okay. So this is the answer, okay. Formation of 1 molecule of glucose, how many molecules of carbon dioxide, NADPH2 and ATP are required? However, 1 molecule of glucose, we have already discussed it. How many molecules of carbon dioxide? 6. How many molecule of NADPH2 required? Yeah, for the 1 glucose, here the 12, okay, and ATP it is 18, okay. Now PGA was discovered in which organism? Phosphoglyceric acid, first discovered. Who? Melvin. So how? There is a radioisotope, and which organism it was utilized? She said chlorella, it's alga, chlorella, okay. It is also unicellular organism, unicellular alga, okay. It is actually a photosynthetic algae. However, the PGA formed during Kelvin cycle, how many PGA formed during Kelvin cycle? The source of carbon for this formation, okay. The answer this question is PGA, that is 3 carbon compound PGA is formed. Its carbon source are actually obviously the carbon dioxide of atmosphere, not the RUBP, okay. You don't be confused about that. So RUBP's part will be used in formation of PGA. No, formation of PGA is solely dependent on carbon dioxide of atmosphere. In C3 cycle, first carbon dioxide acceptor molecule, in C3 cycle, first carbon dioxide acceptor molecule is 5 carbon compound, remember, that is RUBP, ribulose 1,5-bisphosphate, and the enzyme is ribisco, the most abundant enzyme of our world, of our universe, okay. So this is actually the doubt questions. I am discussing the next doubt questions here. Now the next question is that the Kelvin cycle perform in which plant? Okay, the Kelvin cycle perform in which type of plant? Actually, it is present in C3, in C4 and in CAM. Only absent in photorespiration. Okay. Kelvin cycle perform in C3 plant, C4 plant and CAM. Okay, the Kelvin cycle perform when? In C3 plants where, in C4 plants where, in CAM plant where. You have to remember it. So in C3 plant it is mesophyll, in C4 plant it is bundle seed cell, and in CAM in mesophyll also. Okay, now for the synthesis of one molecule of sucrose, how many molecules of ATP and NADPH are required? We know that for one glucose through Kelvin cycle it is 18, okay, ATP and 12 H2. So one sucrose means 2 glucose. So 2 glucose in 2 into 2. So it is 36 and it is 24. It is ATP 24 NADPH2. Okay, it is clear. So question may be confusing. Okay, here sucrose is given. Now how many molecules of ATP are required to regenerate one RUBP? Okay, one RUBP for only regeneration required 1 ATP. Okay. In which phase of C3 cycle does not require any energy rich substance? No energy rich substance is required. Your carboxylation, first step, second step. First step carboxylation, second step is what? So it is the reduction and then regeneration. Okay, so regeneration require ATP, reduction required ATP as well as NADPH2, and Kelvin carboxylation required no any. So this is the answer, that is which phase of C3 cycle does not require any energy rich substance. Okay. Another type of questions, another peculiar type of questions can be asked, that if atmospheric carbon dioxide concentration will be high, what will happen? If atmospheric carbon dioxide concentration will be low and oxygen concentration will be high, what will happen? So let's see. We know that our enzyme is Rubisco. Rubisco whose form is ribulose 1,5-bisphosphate carboxylase oxygenase. This is a specific enzyme. So this enzyme has two parts. These two competitive actually part, where it at a time it will perform as a carboxylase as well as a oxygen. When atmospheric carbon dioxide will be increased, C3 plant will be benefited. Okay, C3 plants will be benefited. When oxygen concentration will be increased, C3 plants will not be benefited. Okay, so oxygen concentration will be high, what photorespiration will be occur due to this Rubisco enzyme, because when oxygen level is high, then this Rubisco enzyme will accept oxygen instead of carbon dioxide and run the photorespiration procedure. So why the atmospheric concentration will be whatever maybe, the plant will survive. Okay, thank you.